Hello everyone, we're now moving on to Lesson 8, and Lesson 8 is all about rational exponents. So no logs! I'm sure you're very excited about that. So today we will be able to relate roots and rational exponents and use them to simplify expressions and solve some simple equations. So the first thing that we have to remind ourselves is the anatomy of a radical. So you guys are probably familiar with what a radical looks like. So we have three pieces to the radical. We have what's underneath it, which is called the radicand. Then we actually have the radical itself, but we also have this little n here, which is going to be replaced with a number, and this is called the index. And we're going to be referencing the index quite a bit in this lesson. So let's talk rational exponents. When you have a fractional exponent, it is equivalent to a radical expression. The index of a radical expression is equivalent to the denominator of a fractional exponent. So here we have a rational exponent of x to the power of m over n. So m over n is a fraction. And we can write this one of two ways as a radical. So our base of the exponent, that goes underneath the radical. Then the denominator of your fraction, so here it is n, it's going on the tail, so it's our index number. Now, this m, there are two spots it could go. It can stay with your base as an exponent, or, so n root x, or we can put parentheses around the whole thing and attach it to the outside. Both of these are the same, and both of them are acceptable when you are rewriting a rational exponent as a radical. Speaking of, let's go over our first few examples. These first two examples are going from rational exponent to a radical. So the first thing I always do is I write the radical first, and then I place the index number. Remember, the index number is the bottom of your fraction. So here we have x to the 4/5. 5 is in the bottom, so 5 is my index number. Then the base. My base is x, so it goes underneath. And now you get to make the choice of where you want to put that 4. Do you want the 4 to stay inside with the x? Or you can have the 4 on the outside. If you choose to put the 4 on the outside, you have to make sure you put parentheses. That's the only thing you have to make sure you do if you put the top number, the numerator, on the outside. So here, next one, start with our radical. 3/5. So our index is 5 again. The base of our exponent is y, so it goes underneath the radical. And then 3. We can either keep that inside or put parentheses and put it to the outside. So that's going from rational exponent to radical. Our next two examples are going from radical to rational exponent. So this one we start with the base. Here we have the third root of x to the 5th. So my base is x. Then I know it's going to be a fraction, so I'm going to put my fraction bar. Remember, the bottom of your fraction is the index number. So my index number is 3, so the bottom of my fraction is 3. And then attached to my x is 5, that is my numerator. So my rational exponent is x to the 5/3. All right, this one, square root of a. So a is my base. We know there's going to be a fraction. Now, here's the big thing you have to remember. When you have a square root, even though there is no index number, technically it is a 2. So we're going to have 2 in the denominator, And since we do not have another exponent, it is just 1. So this is a to the 1/2. All right. Now we're going to do some simplifying. But before we do that, we have to remember how to simplify some radicals. We have done simplified square roots before. The concept is the same when you have a larger index number. So our steps are to break it down into prime numbers using a prime number tree. So let's say we have the square root of 20. We're going to break 20 down into prime numbers. 2 and 10, 2 and 5. Then we circle, and we're going to group them together. 2 times 2 times 5. Find groups that they're the same size as your index number. So here, square root of 20, my index number is 2, so we want groups of 2. So there's a group of 2. Then, in those groups, keep 1 and chuck the rest. So we keep a 2, chuck a 2, and then the non-group numbers stay inside, and then do any simplifying with multiplication. So here, 2 root 5. So this is just a refresher. You should vaguely remember us doing this in semester 1. All right. So what we're going to do to simplify these is you need to rewrite each rational exponent as a radical first and then simplify if possible. So here, 25 to the 3/2. So this is going to be 25 underneath the radical. My index is 2, so it's a square root. Now, when I'm simplifying, I always go the parentheses route, because I like to see if this can simplify. So here, square root of 25, it does simplify. Square root of 25 is 5, and then we have it to the 3rd, and then we calculate 5 to the 3rd, which is 125. All right, this next one, 32 to the 3rd, times 1/5. I'm actually going to combine these exponents and have this be 32 to the 3/5. So now we rewrite this as the 5th root of 32 to the power of 3. So now we take the 5th root on our calculator, and that is going to be 2 to the 3rd, which is equal to 8. Now, you're not always going to simplify it down to a whole number. In the next video and on the next page, we're going to talk about what happens when you can't simplify it down to a whole number.